So, significant figures. Can somebody tell me what do they mean when they say significant figures? يعني in other language, either in Arabic or use another word for significant. Can somebody؟
الأرقام المهمة.
المهمة، أي نعم. إيش كمان؟ special، لا مش special. Numbers give more accuracy، لا مش more accuracy. Significant figures it's زي ما قال زميلكم اللي هي the important figures in our measurement. ولما نقول when we say significant figures معناته we are talking about experiment. We are talking about experiment. يعني في measurement، في kind of measurement. Significant figures in mathematics يعني if you are doing just mathematics you can get rid of them. But if you are doing problems with measurements معناته you need to pay attention for significant figures. وبما إنه most of physics problems are based on measurement يعني you have distance, you have speed, you have time, calculate the acceleration, calculate the velocity, etc., etc. It's all measurements, and then significant figures will come and play an important, very important role. Very important role. For example, suppose that in your account in the bank, suppose inshallah يعني everybody has this amount, you have 100,000 and 977 Qatari riyal. When you want to tell somebody how much do you have in the bank, what do you say? Most likely you'll say 100,000. Most likely you'll say 100,000. طيب, in the 100,000, which numbers are the significant? Those. تمام? هلا some of you wrote 101 because they have some background about significant figures because you need to discard this, so because it's more than 5, so they say 101 قطر ريال. The main point إنه remember when I told you order of magnitude that we use it in real life. We are expert in order of magnitude in real life. However, we need to transfer this experience from real life to physics. Significant figures, we always use significant figures in real life. When we pass information, always we use significant figures. For example, I will ask you, well, your friend Abdullah, how old are him? You will tell me, well, he is 20 years old, or 21 years old, or 19 years old. Anybody ever will mention when he is asked how old is Umar مثلا or Muhammad, he will mention the days and hours and seconds in his life from his birthday. Why? Because everybody use this concept, the significant figures, the important numbers that will answer the question. So this is just as an introduction for the feeling. What do we mean by significant figures? And again, significant figures will play a role when we have a measurement. When we have a measurement. I ask you, how old is Umar? And you answer, neglecting days and months and hours. because you did a measurement. You did a measurement. So let's see the rules. Let's see the rules. And an appetizer. How many significant digits are here? Well, for your surprise, it's only 2. It's only 2. Why it's only 2? Because, well, the first rule, zeros to the right of the number are not considered significant. Why, ya Ustad? Well, let me give you an example. 1 kilogram. How many significant digits? 1, correct? طيب, I will ask you how much 1 kilogram in grams. So you will write 1,000 gram. So here is the rule. Converting the units will not add accuracy to the measurement. What's the accuracy? It's 1 digit. When I say a kilogram. طيب, converted into a gram, it's 1,000 gram. Converting the units will not add to the accuracy of the measurement. لأنه حكينا significant figures معناته في measurement. في measurement. So when you convert the unit, it will not affect the measurement because the measurement is completely independent from the units. تفضل يا خالد. Khalid, you raised your hand, or by mistake, ya Khalid. Okay, by mistake, most probably. So, they invented the first rule. Zeros to the right are not considered significant figures.
اللي صوته واضح.
تفضل يا خالد.
اعتذر المايك كان خربان.
سلامة المايك تبعك.
بالنسبة للكيلوغرام، من الكيلوغرام للجرام لما نحولهم. بس السمستر اللي فات مع أخذت الكيمستري أعتقد قالت إنه one infinite number، مش عارف لما نحول من وحدة لوحدة infinite significant numbers.
لا مش صحيح. No. Either you misunderstood of what she said or there is something wrong. We stick with the accuracy of our measurements. لما نحولها من unit لunit we will keep the same accuracy. يا عمرو.
إذنك يا دكتور، بس عندي تعليق بسيط. بس احنا كنت خدت السمستر اللي فات عندي كيمستري، فخدت فيه significant figures. فالدكتور قال لنا لما مثلا تكون عندي مثلا رقم زي 1500، هنا احنا مش متاكدين اذا كانت significant figures هي عدد 4 أو 3 أو 2 أو 1، انما احنا بنتاكد لما يكون في بوينت. يعني على سبيل المثال مثلا المثال اللي بعديه هو كده 4 significant figures تمام، انما اللي هو المثال اللي فوق اللي هو 1500 بس احنا كده مش متاكدين، فما ينفعش نحكم نقول 2 بس موجودين. فده على حد علمي يعني.
هذا بالكيمياء.
ايوه
بسموهم بالكيمياء هدول ambiguous numbers. تمام. احنا بالفيزياء we consider ambiguous are non-significant.
تمام.
يعني الكيمياء
ما اعتبرش يعني ما اعتبار الاصفار خالص.
صحيح.
الاعداد بس.
صحيح.
تمام.
بالكيمياء بسموهم ambiguous numbers، يعني it could be significant و it could be non-significant. هلا بالفيزياء سواء اللابس لما تاخذ اللاب 192 we consider them non-significant من البدايه non-significant. تمام. وبالفيزيكس بنفرق بين 1500 و 1500.0. هذه 4 significant digits، هذه 2 significant digits. يعني الكيمستري بسموهم ambiguous، بس احنا بالفيزياء خلاص اذا if they are significant you need to put a dot. If they are not significant we just write it without a dot. Yes. هلا زميلكو كتب 1 kilobyte is this. This is 1 kilobyte. Yeah, this is 4 significant. But I didn't say kilobyte. I said kilogram. I said kilogram. Same thing. We can do the reverse. I did a measurement for 1 gram. Convert this into a kilogram. Correct? Well, converting the unit will not add to the accuracy of the measurement. لأنه significant figure معناته we have measurement. We have measurement. So to convert the unit, it will not affect the actual measurement. فهو إذن zeros without decimal from the right does not count, or zeros to the left, even if there is a decimal, does not count. يعني we covered already 2 rules of the significant figures. طيب, let's go back here. So how many significant digits is this? 4. How about this one? 3. How about this one? 2. Correct? Why? Because if there is a decimal, it will just, all the numbers will be significant. One exception for the decimal is zeros from the left. But other than that, if there is a decimal, everything is significant. Everything is significant. زي هذا المثال, this example, 2.3 10 to the power minus 4. Well, we have 2 zeros to the left. That means they are not significant. However, this number is 3. This number is 2. Why? Because the 0 is to the right after a decimal. It is considered significant. It is considered significant. Okay? Also, one important thing, we need how many? That's 3. Awesome. طيب. In mathematics, هي احنا math. This is math. 1 equal to 1.01 equal to 1.001. In math. When you do a measurement, سواء physics, chemistry, biology, etc., those are completely different values. They are not equal. When you do a measurement, those values are not equal. When you do mathematics, those values are equal. You get the point? Of course, the more significant digits, the more accuracy you have to your measurements. This measurement is more accurate than this measurement and more accurate than this measurement. It's accuracy. And again, I will tell you what's the meaning of significant figures is that means you are doing an experiment. You are doing an experiment. هلا, so those are the rules to consider significant figures. الحين when you do the lab, but same value in mathematics. In physics, they are not the same value. Physics, chemistry, biology, those 3 numbers are not the same value. They are not the same values. In mathematics, yes, it's the same value. Experimental science, they are not the same value. They are not the same value. طيب. الحين when you take the lab, physics lab or chemistry lab or whatever, sometimes you have to multiply two measured values, or add or subtract for two measured values. So they made a rule for that. They made a rule for that. Multiplication and division, it's a very simple rule. Multiplication and division, it's a very simple rule. We always go for the smallest number of significant figures. Always. Multiplication and division. So for example, use your calculator. This is the area of a circle. Use your calculator. Pi multiplied by 6, it will give you this number. However, that number in mathematics is correct. In physics or labs, that is wrong. That is wrong. Why? Because when you do multiplication or division, we go for the lowest number of significant digits. طيب, in this equation, what's the smallest number of significant digits? Well, pi is unlimited, لأنه pi is 22/7. It's 3.14, etc., etc., etc. It's unlimited significant figures, pi. However, how many significant digits here? 6.0. It's 2. That means the answer has to be 2. So this is the answer when you enter your calculation. So you have to convert into two significant digits. So 1, 1, that's it. Now I need to deal with the rest of the number. If it is less than 5, it's just a 0. Centimeter square. Of course, this number is two significant digits, and this number is two significant digits. In chemistry, this is confusing, it's ambiguous, but in physics already we said we consider it a non-significant digit. If it is a significant digit in physics, we'll just write it like this. Now this is 3 significant digits. But in physics, if we write it like this, that's for sure 2 significant digits in physics. In chemistry, it's a different way of approaching significant digits. Okay, so that's for multiplication and division. Any question? Always we go for the smallest number of significant digits. Well, it's the same. 1.1 10 to the power 2 is the same as 110. 110 are 2 significant digits. Of course, you can write it in scientific notation. Sure. طيب, let me test your understanding. We have 7,451 multiplied by 1. What's the answer? 7,000. ممتاز يا عبد الرحمن. No. Abdullah, no, that's wrong. It's just 7,000. It is just 7,000. No, not 10 to the power 3. No. It's just 7,000. Yes, you can write it as 7 10 to the power 3. Sure, you can. طيب. What's the answer? 8,000. Correct. Correct. Now you understand what do I mean by that. Or, for example, let's do it division. Want to make a difference. Division won't make a difference. Okay. Now let's come to addition and subtraction. Addition and subtraction. For addition and subtraction, we go for the biggest decimal. The biggest decimal. Yani, let's try to read. When numbers are added or subtracted, the number of the decimal places in the result should equal to the smallest number of decimal places of any term in the sum difference. يعني شو يعني smallest? Here, how many digits after the decimal? 3. Here, how many digits after the decimal? 1. We always go for the smallest one. We always go for the smallest one. So that means this is the result on the calculator, but we should have only one number after the decimal. We should have one number after the decimal. So I need to get rid of those. Because they are bigger than 5, it becomes 4. Addition or subtraction. Clear? Let me give you an example. 1.1 minus 0.01. What's the answer? What's the answer? 1.09, that's in mathematics, but when you deal with significant digits, it's 1.1. Because what's the result on the calculator? I'll calculator. 1.1 minus 0.1. The result on the calculator, let's do it here, 1.09. But here we have one digit after the decimal. So the answer should be one digit after the decimal. So we need to get rid of the 9. So come back as 1.1. 1.1. It's not 1.09. 1.1. Again, addition, subtraction are a little bit more confusing. We look for the least number of digits after the decimal. Here we have one number after the decimal. Here we have two numbers after the decimal. So the answer should have only one number after the decimal. No, you can't write 1.110 because 1.1 is not equal to 1.10 in physics or in experimental physics or experimental chemistry or experimental biology. Those two values are different. They are not equal at all. In mathematics, yes, they are equal. Okay, so let's take this example. I think that's the last one. When you multiply these two numbers, you will get this number on the calculator. However, how many significant digits should I have in the final answer? Here it's 3. Here it's 4, so I should have a 3. Convert this into 3 numbers, so it will be 4.0. Okay? Okay, so this will conclude chapter 1. Let me stop the recording so we can start chapter 2.